It's pretty wild. We have AI that can write poetry, it can debug computer code, it can even help with major scientific discoveries. And yet, that same AI can fail at tasks that a child would find, well, trivial. So let's dive into this really fascinating paradox.
Okay, imagine we teach an AI a simple, straightforward fact. Something like, Pei-Young Song is the author of the paper Large Language Model Reasoning Failures. That's it. A is B. Simple enough, right?
So, now let's just flip that around. If Pei-Young Song is the author, then who is the author? Well, it's Pei-Young Song, of course. For our brains, that's a no-brainer. It's the same information, just reversed. But this is where it gets weird. For a lot of the most advanced AI models out there, this is a huge, huge hurdle. It seems they can learn information in one direction, but they can't just flip it around. And this isn't some random bug. It's a fundamental weakness that tells us something really profound about how they think.
This specific kind of failure even has a name. They call it the reversal curse. It's a well-documented thing where an AI trained on A is B totally struggles to figure out that B is A. And again, this isn't just a one-off glitch. We're talking about a pattern here.
And this is where things get really interesting. Researchers are now moving past just pointing out these funny mistakes. They're actually creating a whole science of AI failure by systematically mapping out all the blind spots in how AI reasons. See, when you start to understand these patterns, you can do a lot more than just patch individual problems. You can start to dig into the deep, architectural reasons why these failures happen in the first place. And that's the first real step toward building AI that's truly robust and reliable.
And this image right here, it's the perfect example of this new approach. It's the first ever comprehensive map of AI reasoning failures, put together by researchers Song, Han, and Goodman. Think of this as our guided tour map for the rest of this explainer.
So, this map is basically organized in two ways. Down the side, you have the type of reasoning we're talking about. Is it social? Is it logical? Is it about the physical world? And then across the top, you have the type of failure. Is it a really deep fundamental flaw, or is it more of a specific weakness? So let's use this map and take a little tour of AI's biggest blind spots.
First stop on our tour is what's called informal reasoning. This is all that intuitive, common sense thinking that we humans use to get by in social situations, pretty much without even trying. For an AI, though, this area is an absolute minefield.
So if you look at our map, we're starting right here in the informal reasoning category. This whole section covers stuff like cognitive abilities and social interactions.
And what's kind of wild is that AIs don't just fail in weird, robotic ways, they also fail in very human ways. They actually show the same kinds of cognitive biases that we have. Things like confirmation bias, or getting tripped up by the order you ask questions in, or getting stuck on the very first piece of information they see. Sound familiar?
Now, another huge challenge for AI and social reasoning is something called theory of mind. This is a core human skill. It's basically what allows you to understand that other people have their own thoughts, their own beliefs. It's what makes us social creatures.
And get this, even the most powerful, cutting-edge AI models really struggle with these classic false belief tests. Tests that young kids can pass with no problem. And that's a big deal. It means the AI can't reliably guess what you're thinking, which is a massive barrier to any kind of true human-like conversation.
Okay, so AI has a hard time with all the soft social skills. But it's a computer, right? So surely it's got to be great at hard logic and math, right? Well, let's take our tour to the next stop, the world of formal reasoning.
All right, next stop on the map, formal reasoning. This is all the rule-based stuff like logic and math, where you might be surprised to hear the failures are just as weird.
And look who's back, our old friend, the reversal curse. The researchers classify this as a fundamental failure. It's not just a little quirk. It shows that the AI has basically just memorized a pattern. It hasn't actually understood a relationship. It's like the training process creates this one-way street for information that our minds just don't have.
What else breaks down in here? You're not going to believe this one. Counting. Simple counting. That's right. Many of these incredibly powerful language models, which can write a whole essay on quantum physics, fundamentally struggle to count the number of letters in a word. It just goes to show their intelligence is all about predicting text patterns, not real conceptual understanding.
All right, for our final stop, let's move out of the abstract world of logic and into the concrete physical world. This is what's called embodied reasoning, basically understanding how stuff works in reality. So our final stop on the map is right here, embodied reasoning. This is all about an AI's gut feeling for the physical world, or lack thereof.
You know those what's wrong with this picture puzzles from when you were a kid? You see a fish flying in the sky or a car with square wheels. For us, spotting what's wrong is instant. For an AI, not so much.
And the reason is actually pretty simple. AI doesn't have a body. It learns about things like gravity and friction just from text and from images. It doesn't really get the affordance of an object, what you can do with it, like using a hammer for a nail. It's missing that lived physical experience that gives the rest of us our intuitive common sense.
So after this whole tour of AI failures, you might be thinking it all sounds a bit doomed. But here's the twist. The researchers argue the exact opposite. They believe that systematically studying all these mistakes is actually the clearest and most direct path to success.
They even open their paper with this brilliant quote from Malcolm Forbes. Every single failure, from the reversal curse to not being able to count, is like a breadcrumb. It leads us back to a fundamental piece of the AI's architecture that we can then understand and hopefully improve. So this map of failures, it's really a blueprint for a success.
And that leaves us with one last thing to think about. As we get better and better at teaching AI how to think, its strange and sometimes very human-like mistakes hold up a mirror. They don't just reflect the limits of an artificial mind. They also show us the hidden complexities of our own. So as AI gets smarter, what can its blind spots still teach us about the things we all take for granted?